Hello friends, welcome to Silan Software. Now, in this video, we will see a project that is hot disease prediction using logistic regression. So, it is a machine learning project in data science. So, logistic regression is one of the classification algorithm in supervised machine learning. So, classification algorithm. So definitely outcome will be a categorical value, whether it will be 0 or 1. So our problem statement is heart disease prediction. So first of all, we will collect data, or we will bring a data set from Kaggle. Yes, you see, so from this Kaggle, so you can collect the data. So here you can download already. I have this data set, that is heart.csv file, and it is a such data set containing some features like age, sex, chest pain type, resting blood pressure. So in this way, 14 features that we can get in heart.csv files. So you can download here also. This is the download option, you can download. So I have downloaded. So I have downloaded this data set. You see, this is my data set. Okay, and you see the last column is the target column, that is 0 and 1. So that column is the output column. So 0 means the candidate having heart disease, or sorry, the 0 means the candidate having no heart disease. 1 means the candidate having heart disease. So first column is the age. So age column is the what age of a patient. Then sex column. So 1 or 0. So 1 means male or 0 means female. It have encoded. CP, chest pain type. This is another column actually. Type of chest pain explained by the patient. So it have encoded also. And 0, 1, 2 or 3. Okay. 0 means typical angina. 1 means atypical angina. Non-anginal pain. So asymptomatic. So like this is the chest pain. This is one column. Resting blood pressure, T rest BPS. Resting blood pressure, it is describing what it is representing. So resting blood pressure in millimeters of mercury. So then next column is your serum cholesterol. Then FVS, fasting blood sugar. Then this is what rest ECG, resting resting cardio, electrocardiographic results. Okay, so basically these are the columns, or these are the features. Okay, so hull ACH, maximum heart rate achieved. Then action, exercise induced angina. Old peak is one column. Slow CA, number of major vessels colored by fluoroscopy. Thal means thalassemia, and target is my target column, output column. So 1 means heart disease present, 0 means heart disease absent. So in this way, this heart.csv file containing 14 features, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 number of features. So by taking this data set, by taking this hot.csv file, so we will develop a project. Okay, so directly we will go to my environment. So here my environment is Google Colab. Okay, so I will create a new notebook. Okay, so I will give a file name. So let hot digits prediction using logistic regression. Using logistic regression. Okay, in machine learning. So like in this way I gave the file name. Okay, so first of all I will import libraries. So import libraries. So first of all I will import numpy as np, then import pandas as pd, then import matplotlib.pyplot as plt, import cburn as sns. So first of all I will import this libraries like numpy, pandas, matplotlib and cburn. So now I will hit run. So after importing library, we will bring our data set hot.csv file into my environment in the form of data frame. So you see, first of all, the data set hot.csv file I will bring. So here you will click here and you see upload. I will go to my folder where I have stored my data set. So hot. Okay. So in this way, I brought hot.csv file into my environment. So now I will create a data frame. So create a data frame or load the data set. So we know how to create a data frame. cd.read underscore csv function. So how to create a data frame? There is a built-in function named as read underscore csv function which is coming from pandas library. That's why when it is invoking by pandas alias pd, then it is returning a data frame. So within bracket, so I will write file name heart.csv file. So df.head function. So first 5 records if I want to see, then head function I will call. So first of all, by taking hot.csv file, I will create a data frame. Now I will hit run. You see, in this way, the data set I brought into my environment. So these are the columns age, sex, CP, this. So last column is the target column. Okay, so if I want to know how many number of rows and columns to get the number of rows and columns. So data frame name dot save keyword, I will hit run. You see 1025 number of rows and 14 number of columns. Okay. So then if I want to know some basic information about a data frame. Okay. So to get the info, to get the detailed information, about your data frame. So which function I will call? So data frame name dot info function. Data frame name dot info function. Now I will hit run. And you see the basic information About the data frame that we got, you see 1025 entries, that is 0 to 1024 number of what indexes rows. Zeroth index row representing first column, one index row representing second columns. In this way 1024 index row representing 1025 number of rows. Similarly, data columns, total 14 number of columns. Okay, and these are the column names, and all are non-null values. And these are the data type. All are int 64 type of data. That means all are numeric data. But one is float 64. Data types float 64 within bracket one. That means one column value data items float 64 types of data item, and 13 column values are in the 64 types of data items, and this is memory usage 112.2 kilobytes. This memory has required, have what acquired. Similarly, we will go to the next point. If I want to know the statistical information, to get statistical information about data frame, so which function I will call data frame name dot df dot describe function. Describe to get the statistical information. Okay, so this is the what statistical information. You see, first column is, so each column, so some terminology, statistical terminologies that we have got. The value, count value 1025, this is the mean value, this is the standard deviation value, this is the minimum data item. So 25 percentage values are less than from this value 48 in each column. 50% values are less than from these values in each column. Similarly, 75 percentage values are less than from this value in each columns, and thus maximum data item is this. So this is the analysis for one column. Similarly in other columns, count value, minimum value, mean value, standard deviation value, max value, then 25%, 50%, 75% is, so values from this value of the corresponding column. So overall, so this is the statistical information in detail about the data frame. Then we will go to the next point, to check missing values. To check missing values or null values in my data frame. So how to check data frame name df dot, there is a function is null function dot some function. Actually is null function returning a boolean value, true or false. True means missing value, false means no missing value. So if I will add another function dot some function, so it will count this column having this missing value. If 0 having no missing value, you see, if I will hit run, you see is 0 6 0 cp column 0 t rest bps 0 col 0 fvs 0. That means all columns having no missing value. 0 means no missing values or no null values. So in this way, so we saw to check missing values, to check missing values. Okay, so then we will go to the next point. We will make a plot. First of all, we will find the correlation matrix. Okay, so we will go to the next point. So why correlation matrix? Why correlation matrix? Correlation matrix, because correlation matrix is a such matrix which is identifying or which is establishing the relationship between variable and variable, between feature and features. So correlation matrix, suppose if I will call, there is a built-in function CORR. Okay, so data frame name dot CORR function, it is a built-in function. If I will hit run, so I will get correlation matrix. This is a correlation matrix values. But if I want to establish a relationship between feature and feature, okay, so what I will do, I will make a plot. Okay, so by taking correlation value, so I can create a plot. So I can create a heat map. Okay, so I can create a plot. I can create a plot. So create a heat map. So create a heat map taking correlation matrix value, correlation correlation matrix value, correlation matrix or correlation matrix values, correlation matrix. Okay, so first of all, I will write plt dot figure. So width and height I will first specify. So within bracket I can write figure size equals to let 15 comma 10, width is 15 inch, height is 10 inch. Okay, so then I will call which function for generating heat map. There is a built-in function, heat map function coming from cborn library. I can call by cborn alias sns. So I will write sns dot heat map function. Okay, so heat map function, it is a built-in function which is coming from cborn library. So that's why I invoked by cborn alias sns. So I am writing sns.heatmap function within bracket. So I will write df.curr function. Okay. So by taking correlation matrix, so another parameter I can take line width equals to, let it whatever I can give, suppose 0.01 whatever, then unknowns equals to true, so the correlation matrix value will display. So cmap, another parameter, color map equals to one predefined color map. I can write, let this is winter. Okay, so in this way, so I called a heat map function, and display the plot I will call the show function, plt dot show function, then I will hit. Okay, so you see one heat map. You see, so one heat map we got. Okay, so heat map we got actually, and from this plot, from this heat map, we can get lots of things. So which things that we will get? So definitely, you see, there is a feature CP. Okay, there is a feature CP, that means chest pain, and there is a feature target. You see, there is a positive value. Okay, that is 0.43. There is a positive value. Okay, so this positive value, what it is representing? Okay, from this heat map, so CP is one feature, chest pain. Target is one feature. So the purpose of heat map is what? Identify or establish the relationship, how strongly correlated. So CP and target has having a positive correlation because 0.43. So it is a positive value. So that means definitely the patient has a large risk of chest pain, which results in a greater chance to have heart disease. Okay, so chest pain, thalas, you see thalas 0.42, it is also a positive relation. So with respect to target, thalas and target similarly slope and target is a positive correlation. So with this target, okay, so this suppose exam, where is exam exercise induced angina, exam and the target having a negative correlation, which means we exercise, the heart requires more blood, but narrowed arteries slow down the blood flow actually. So that means what? My point is, this variable and target, it is representing a negative correlation, whereas this variable CP and target is representing a positive correlation, slope and target representing a positive correlation. So from this point of view, we are observing what? If the positive correlation, if the positive value that we are getting, that means the patient, suppose chest pain, patient having high chest pain, if the patient having high chest pain, so which is meaning what, which is representing what? So greater chance, major chance to have heart disease. Okay, so this is the point actually. So this is all about heat map. Okay, so heat map we plotted by taking the correlation matrix, and this heat map, every feature to feature you can identify the relationship: age target, sex target, CP target, test BPS target, coal target. So identifying the or establishing the relationship between feature and feature. Okay, then we will go to create another plot histogram. You see, before creating logistic regression model, whatever we are doing, so that is considering as data pre-processing, or we can say ADA, exploratory data analysis. So our objective is what? Overall, our objective is we will create a logistic regression model. Then the logistic regression model, it will be trained. Once it will be trained, then it will become intelligent. Once the logistic regression model became intelligent, then logistic regression model will predict over the testing data. Later on we will discuss. Then we will see logistic regression is predicting what. Then we will find the accuracy by taking actual output and prediction output. Okay, so coming to this point, after heat map, so if I will create a histogram plot, if I want to see the relation between each feature distribution, if I will see, then I will make a histogram plot. Create a create a histogram. So it is another plot. Okay, so I can write df dot, there is a function hist function actually. So same way I will specify the parameter fixed size. So let it, I will specify width and height 12 12. Okay, so if I want to save this figure into a file, okay, so there is a function plt dot save fig is a function. It is optional, so I can specify any name. Let feature plot. So what is the purpose of save fig function? So it is saves what are the plots generated to a file. Okay, and the file named as features plot actually, and the file meaning is what? So current saves the current figure to a file, and matplotlib what defaults to saving a file in a .png format actually. There are different format, there are different extensions, .png, .jpg, .pdf. But in this context here, what particular what format we are not specifying. So matplotlib will consider it is a .png format. So savefig, this line is optional. So savefig function simply saving our plot to a file, and this file named as what? Features plot. So basically what we will see the relation between each features distribution. For this we have created what histogram. I will hit run, and you see this is a histogram that we can get also. I can use another parameter. Suppose if I will write age color suppose equals to r. Suppose age color, if I will hit run, you just will see. Okay, so it is clearly identified actually the distribution 40 to 60 this 0 to 40, how many number of candidates are affected. So 40 to 60, what is the distribution? 60 to this, what is the distribution? So for each feature, so I have tried I have tried to display each features distribution, okay. In this is for age column, this is for sex column. So this what from the beginning, uh, so I have told actually sex. So sex column means one means male, zero means female. So this is the distribution for female side, this is the distribution of male side. So in this way, so each features distribution that we saw in with the help of histodiagram, with the help of histogram, with the help of histogram. So then this is all about the plot. So in this context, we created two plot. One is heat map and one is histogram. Then we will go to the next point. The concept is saying the entire data set, the entire data set, we will split. We will split the entire data set. We will split into training and testing data set. The entire data set we will split. So before that, so we will split into training and testing data set. And for this, we need X and Y. So what is X? We need choose X and Y. So uppercase X representing independent variables or input variables, lowercase y representing target variables or output variables. Independent variable means input variables. In a data set, we can consider one column as input variables or more than one column we can consider as input variables. So in our context, output variable is the target column. Okay, so this is, I will consider this column as our output variable, and all so remaining columns are we will consider as input. So input variables, input features, so I will consider as uppercase X. Output variable or output feature I will consider as lowercase y. So you see the output is, this is the -1 index value if I will see in this way. Okay, so in this way, this is 0th index column, this is 1 index column, this is 2 index column. In forward way, if I will see, but in backward way, if I will see, so this is -1 index column, this is -2, this is -3. So up at -1 index column, all whatever the columns or whatever the remaining columns, I will consider as input. So you see how I'm choosing X and Y. So in pandas concept, there is a concept iloc. So using iloc concept df. So x equals to df dot iloc. So in pandas already I have given the clarity what is the purpose of iloc. So I will write colon comma colon -1. So colon comma colon -1 means colon means all what features will values will display, all features, all the records of all columns will display. uh, Colon, then colon -1 means apart -1 index, apart -1 index column, all column values will display. Okay, column means all the records values will display of all columns, but after comma colon minus 1, colon minus 1 means apart minus 1 index. If simply colon comma minus 1 if I will write, then that will represent minus 1 index column values. But after comma colon minus 1 means apart minus 1 index columns, whatever the remaining columns that we have, so that corresponding values with columns we will come, the columns values or columns whatever in which way that you can understand, so that I will consider as x and y equals to, similarly I will write df dot ilog, then colon comma minus 1. Colon comma minus 1 means minus 1 index column. So minus 1 index column, that is the last column, that is the target column. Okay, so target column is my output variable, and remaining columns are input variable or input feature. So in this way I will choose x and y. I will hit run. Then I will go to the next point. So what I told currently I was telling, so I will split the data set into training and testing data, into training and testing data. So how I will split, for this one built-in function that I will import, so that is train underscore test underscore split. So this is coming from sklearn library. So in machine learning, sklearn library is a very important library, is the main important library. Every required built-in function if I want to use, so that is coming from sklearn. So from sklearn dot model underscore selection, so I will import train underscore test underscore split. Okay, trend test split I imported, which is coming from sklearn dot model underscore selection. Sklearn is a what module? Model underscore selection is a sub module. Okay, from Bhubaneswar dot Joydev import Silan Software. In that way, actually, sklearn is a module in Python library, is a module container. Okay, so inside sklearn library, there is a sub module, that is model underscore selection. And from that sub module, so trend test split function is present. So I imported trend test split. So this trend test split function, I will call trend split function. I will call. So within this function, so I will pass the parameter x comma y comma test size, so equals to 15%, 20%, 25%, 30%. Suppose I will take 0.25, a random state equals to any positive, any integer value. I will explain what is this. So trend test please, it is a built-in trend underscore test underscore split. Trend test split is a built-in function taking four parameters x, y. Test size is 25% and another parameter random states. So it is a built-in function which is returning, which is returning, which is returning four numpy arrays, which is returning four numpy arrays. Let xtrain xtrain xtest y train comma y test, like in this way I wrote. So train test plates, very important point, again I'm repeating. So concept is saying the entire data set we will split into two category. One is training data and one is testing data. All the data are considering training data. From that training data, 25% data item I will consider as testing data, because model will what predict over testing data, and from that testing data whatever the model predicts, so accordingly So we will predict overall. So then test a split function returning 4 numpy arrays. Okay, now I will hit run. And what is the purpose of random state? Random state minimum is this. This is the mandatory parameter. And random so whether you can specify or not, you should, it will be better you specify. So what is the purpose? It ensures reproducibility of the split by using fixed seed for the random number generator. That means by setting random state equals to any integer value 42 here, I have written the same split is produced every time the code is run. So any integer value, so I will take this parameter. Okay, so now I will hit run. Okay, so after that you can check what is the x test value. You can check. So over this value, this is input. This is input. Over this input, over this input, the model will predict. I can check also y test value. I can check also y test value. So white test. So I will hit run. Okay, so white test is the actual output actually over X test. So over this is the actual output value. Okay, one means having heart disease, zero means no heart disease. Okay, so white test is the actual output value. So our objective is we will create logistic regression model. What logistic regression model is predicting over testing data. Then whatever the prediction we will get by the logistic regression model, that prediction and this actual data. So by taking this, we will find accuracy. This is our objective. So now this is all about data pre-processing or EDA, exploratory data analysis. Okay, so I hope you all are understanding. So now time came, I will create a logistic regression model. I will create a logistic regression model. Okay, logistic regression model. So how to create a logistic regression model? So in Python context, actually, logistic regression, it is a built-in class name. Logistic regression is a built-in class name. So simply, if I will create an object of that class, if I will create an object of logistic regression class, so that logistic regression object will represent the logistic regression model. So let my object name is model. Object name whatever you can write in Python programming. So how to create an object? Object name equals to class name parenthesis. Object name whatever you can take. Suppose I will take the object name is model equals to class name logistic regression class name parenthesis. Okay, so before that, so logistic regression, since it is a built-in class name, so first of all, this built-in class, so we have to import. So first of all, I will import. Okay, so from sklearn, everything is coming from sklearn module or sklearn library. Sklearn dot, there is a sub module linear underscore model import logistic regression. Logistic regression. Okay, from sklearn.linear underscore model import logistic regression single word. So here L is first character is uppercase, first character of the next word is uppercase. It is a built-in class name. This is the naming convention of class name in object-oriented programming. Okay, so first of all, I will import logistic regression. It is what we are importing from sklearn module. So sklearn is a module, linear underscore model is a submodule, and from this submodule we imported logistic regression. Now I created the object of logistic regression. Object name equals to class name parenthesis. So now this logistic regression object representing logistic regression model. Now I will hit run. So in this way, I created a logistic regression model. So once model is created, then we will train the model. So we will train the model. will become fit, model will become intelligent. So how? So there is a fit function. So there is a built-in function, fit function. It is coming from logistic regression class. So that's why it is invoking by logistic regression object, that is model dot fit. And you remember, so always fit function take two argument. One is xtrain and one is ytrain. So X for input, extrain, extrain, Y for output, Y train and Y test. So you remember fit function always take two argument. One is extrain and Y train. When fit function is called, I will hit run, and you see logistic regression model became intelligent. We created logistic regression model, then we trained the logistic regression model. Now the time came, logistic regression will model will predict. Okay, so like fit function, there is another built-in function, predict function. This predict function is also coming from logistic regression class. That's why I will call by the logistic regression object. The object name is model here. I have taken, so model dot predict. Okay, so already I have told prediction model always predict over testing data or by taking testing data. So whatever the model will predict, suppose I will assign in a variable, let my variable name is, suppose whatever I can write y prediction, suppose y prediction, then print, so print y prediction. Okay, I will hit run. So you see, so this is the model predicted output. So this is the prediction value, and this is the y test value, actual value. So by taking this actual and prediction value, okay, so we will find the accuracy. Okay, we will find the accuracy. To find the accuracy, what there are different ways that we can find. Directly, there is a built-in function, accuracy underscore score function I can call, then I can get the accuracy. Or the one of the important point is confusion matrix. Oh, by taking the concept of confusion matrix also we will find the accuracy. Okay, so to get get the accuracy, so what I will import from everything sklearn, everything is coming from sklearn dot matrix. Matrix is a sub module, sklearn is a main module. So I will import a built-in function, that is accuracy score from sklearn dot matrix. Import accuracy underscore score. Okay, you see everything is coming from sklearn. Sklearn dot matrix, sklearn dot linear underscore model, then sklearn dot model underscore selection, sklearn dot model underscore selection, sklearn dot linear underscore model, sklearn dot matrix. So I hope you are imagining so how far this library is important for any machine learning application development. So accuracy score is a built-in function. So directly I just am writing within the output statement. So accuracy underscore score is a built-in function for getting accuracy. So definitely, so I will specify two parameter. One is y test and y prediction, because y test representing actual output. Then y prediction, so model prediction value. So we will take y test comma y prediction, y test and y prediction, and you see I will hit run. So 80%, 0.8050, 0.80. So this is my accuracy percentage. This is my accuracy percentage. Okay, so in this way that we got the accuracy. Another way also we can find the accuracy by using what confusion matrix also. Okay, confusion matrix from sklearn dot matrix import confusion matrix, confusion import confusion underscore matrix. So confusion matrix is one of the important point actually. So confusion matrix is a matrix. So that point, that matrix, first of all we will get, then how I will find the accuracy, that we will discuss. Okay. So same way, so confusion matrix, I will call confusion matrix. So I will call. So there is a built-in function confusion matrix. Okay, confusion matrix. There is a built-in function. There is a built-in function I will call. So within a bracket. So what I will take, same things, y test and y prediction. So y test comma y prediction. So let the matrix, suppose I will assign in a variable, or otherwise we can consider, let the matrix name is CM, suppose. Then I will print CM. Okay, so in this way we can find the confusion matrix. So it is an important point in machine learning. Confusion matrix is a matrix specifically used for performance analysis, okay, to find the accuracy. But under confusion matrix, there are so many terminologies. Coming to our picture, so terminologies that we can get. Okay, we will see first of all what we are getting. If I will hit run, you see I got what, a matrix 99, 33, this is 17, and this is 108. Okay, so I can consider this. There is a term true negative and a true positive, or true positive plus true negative divided by all, this plus this plus this plus this, in this way. 99 plus 33, sorry, 99 plus 108 divided by 99 plus 33 plus 17 plus 108. So whatever we will get the result. So we will calculate. So I will use calculator. 99 plus 108. 99 plus 108. This and this. 99 plus 108. So that is 207. 207 divided by 99 plus 33 plus 17 plus 108, that is 257. So total is 257. So 207, 207 divided by 257. So same result 0.805. Okay, I calculated and it is clearly visible. So this, so actually same accuracy that we got, same this value. Okay, so there is a formula actually. If you can see my videos in our channel, what is confusion matrix, then you can get the clarity actually. True positive plus true negative divided by true positive plus true negative plus false negative plus false positive actually. So this is what confusion matrix, using confusion matrix. You can find some what terminologies like what precision, like precision, recall, F1 score. So you can find out once confusion matrix that we got. Then using confusion matrix also we can create also heat map, or you can write so true positive equals to, suppose if I will write, you see this is what zero, zeroth row, zeroth column, 0 0. Okay, this is 0 1 1 0 1 1 in this way, 0 0. This is 0. This is a matrix, 0 0. This is 0 1 1 0 1 1 in this way actually. Zeroth index, zeroth row, this row, zeroth row, and zeroth column. Zeroth row, one column. Then one row, zeroth column. Then one row, one column. In this way, 1 0 1 1 0 0 0 1. So I can write let true positive equals to, the matrix name is CM, 0, then 0 0. True positive. Suppose I will consider true negative, so that is Cm of 1 1. Okay. So this is true positive and this is true negative. Similarly, false negative equals to Cm of 1, then 0. Okay, 1 0. This is 1 0. Okay. So similarly, false positive equals to, so matrix name Cm, so this is 0, then this is 1. In this way, so I can identify, so what true positive, true negative, false positive. So by taking the formula, so I can find out. So accuracy, so print, so accuracy, okay, accuracy is, total accuracy is what? So simply true positive plus true positive plus true negative divided by true positive plus true negative plus false negative plus false positive. So you can hit run. So you see same output, we got 0.805. So in this way you can find the accuracy. So in which way that I calculated. Okay, so precision, you can find some trained precision value, precision. Okay, so precision for the logistic regression, because we are creating the logistic regression model. So formula is true positive divided by true positive divided by, okay, true positive plus false positive. True positive divided by true positive plus false positive. I will hit run. So precision is 0.75. Okay, in this way you can find the precision. You can find the recall. Okay, so recall, that is also called as sensitivity. Okay, sensitivity. So you can write print. Okay, sensitivity, some another term is sensitivity, specificity. Sensitivity is sensitivity formula is true positive divided by true positive plus false negative. Okay, true positive divided by false negative. Similarly, another terminology I can write specificity. Okay, so specificity, sorry, sensitivity, this is a recall. So specificity, specificity. So these are what uh, terminologies representing what performance analysis of a model. So what is the formula of specificity for logistic regression? Specificity, that is true negative divided by true negative plus false positive, true negative divided by false positive. So in this way, I can get some score. Accuracy is this, precision is this, recall is this, specificity is this. Okay, so in this way that we can find. Also, another way you can find the entire report, precision, recall, F1 score. There is another terminology, F1 score. 2 into precision into recall divided by precision plus recall. So another way, so if you want to see all the terminologies in detail, so there is a built-in function, classification report function you can call from sklearn dot matrix, sklearn dot matrix import classification, import classification report. Okay, so in this way, so if I will call within print function, suppose I am writing classification report. Okay, classification report function within bracket, I will write y test, y prediction. Okay, so now I will hit run. You see, so entire precision, recall, okay, and F1 score. So everything that we are finding. Okay, support the number of actual occurrences of each columns in weight test, precision value, recall value, recall basically what sensitivity. Okay, so in this way, there are various ways that we found or we did the performance analysis. By invoking accuracy underscore score function, we got the accuracy value. By getting confusion matrix, so we got the accuracy value. This plus this divided by total. Okay, true positive plus true negative divided by total. Okay, so in this way we got confusion matrix, then precision, sensitivity, specificity, some other terminologies coming under confusion matrix, that terminologies that we got, so it is representing the performance analysis of the model. So lastly I invoked another function, classification report. So it is providing or it is provided the classification report in detail, precision value, recall value, F1 score value and support value. F1 score is another terminology, to into precision into recall divided by precision plus recall. Okay, so these are the various ways that we presented performance analysis of the model. Then uh, we will go to the next point. So we can what whatever the project we can implement the model. Okay, suppose the meaning is I will take the input, particular input I will take, then what it will give the result whether heart disease is present or not. Suppose I can say, so I will go to the next cell. Let it suppose I will write model implementation, final model implementation, model implementation. Okay, suppose first of all I will take a TOEFL. Okay, suppose one input I am taking. One input, suppose in over X test data. So this is my one input. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So one input, suppose I took and I will specify comma. I will specify comma 124 comma. This is my input 209. So 0 comma then 1 comma then 163 comma then 0 comma 0.0 Yes, 0.0, just will check. Yes, 0.0, then 202. It was 02. So this is comma, then 2, then comma, then 0, then comma, then 2. So let this is my inputs, all the inputs. So I considered or I presented in a TOEFL. So now, first of all, I will convert into a NumPy array. Let my array name is arr1 equals to. So np dot arg array. There is a built-in function, arg array function, and I will specify the input. You see, print arr1. You see, now I converted into a NumPy array. Okay, so first of all, what I did, so one TOEFL, I took, let my TOEFL name is input. So I kept or I assigned whatever you consider to understand all in one input, certain number of values that I brought from X test data, and I converted I converted into what into NumPy array, and this is one dimensional array. Okay, so now objective is very simple. One business logic I will develop, and for this input, the model already we have developed a model name is model already predict function that already we saw. So over the business logic, so model will predict whether by taking this input data, by taking the perfect input data, the model is predicting heart disease is present or not. So now another side, this numpy array I will convert into two-dimensional array because in machine learning context, model takes the input in the form of multi-dimensional array. So this array is one subscript means this is one dimensional array. So what I will do, so I will convert into multi-dimensional array. Okay, so how I will convert into multi-dimensional array? So I will receive. Okay, so I will receive. So arr1 dot receive. Okay, so I will pass 1 comma minus 1. You remember this parameter if I will specify 1 comma minus 1. So let my array name is arr2, and you see print arr2. Now I will hit run. Same things, but it represented multi-dimensional array, two-dimensional, two subscript representing two-dimensional array or multi-dimensional array. You remember, first of all, again I'm repeating, I took input values and I presented in the form of a TOEFL. Let my variable name is input. So this input values I converted into a NumPy array, and I saw that is one dimensional array. Again, I converted into two dimensional or multi-dimensional array. Let the array name is ARR2 because model takes the input in the form of multi-dimensional array. So now by taking the ARR value, ARR2 value, so by taking the ARR2 value, so we will predict. Okay, so predict. So already what model name is model dot predict, model dot predict within bracket. I will take ARR2 value. Okay, so let I will assign in a prediction. Suppose let y prediction. Okay, so let pred. So this variable, so I will simple write the logic y prediction equals to 1. Simple logic, if condition is true, then heart disease the patient having heart disease, having heart disease, yes. So the patient having no heart disease. So in this way, just I developed a business logic. So very simple. My objective is I will develop a business logic, very simple, and based on this logic, taking whatever the input value will take, so you will give the output. Now I will hit run. So you see the patient having heart disease. this output, the patient having heart disease, you see. So by taking this input data, you see. Same way, so by taking next input data, any input data, if you will uh, take here, and so you can get the output very simple. So final A, by taking the ARR value, model predicted. Okay, so this is all about the total project, heart disease prediction using logistic regression. Logistic regression is a supervised machine learning algorithm under the concept of classification. So means outcome is a categorical value 0 or 1. In this context, 0 means the patient having no heart disease, 1 means the patient having heart disease. So I hope everybody got clarity. This is all about the project. Thank you.